Hi, my name is Selassie Dumeno and my partner is Andres Cordova, and this is our homework 6 presentation for Engi 460. So we're going to look at the problem statement, and basically it's a binomial model that is used to mimic share price movements. As you can see, that is the equation, a very long one. And then S subscript I is equal to X subscript I times S I minus 1, where X I is equal to I 0, 1 continuous, and are independent linearly random variables with distribution P X I equals U equals P, and then P X I equals V equals 1 minus P for all I. So basically we have two questions we have to answer. We're first going to simulate the price at the end of each week during the next year when SO is equal to 100 pence, nu is 0.2 per annum, sigma is 0.3 per annum, and H is 1 over 52 years. And then the second one, we're going to suppose that there are 252 trading days in a year. Our H here is 1 over 252. And that for any realization, we're supposed to let S max equal the max of Sj. J equals 0 to 756. And we let the loss equal S max minus S 756 during the next 3 years and selling it after 3 years. And for this one, we're going to simulate 200 realizations of loss and construct an empirical distribution function for it. We're going to do this in MATLAB. So now I'm going to head over to MATLAB and then run the codes and see what our values are. Alright, so in MATLAB we have two separate scripts. The first one is for part A, and then the second one is for part B, which we'll be moving to in a second. So this is a quick overview of the code. We've set all our values. Our S is 100, mu is 0.2, sigma is 0.3, and then our H is 1 over 52. And this is our U equation at MATLAB. And then I'm going to ask for U. And then our V is going to be 1 over U. And then P is the exponent of mu times H minus V all over U minus V. And then when we run that, we're going to get values for this. We're going to get our U, our V, and then our P value. And then what we want to do now is we're going to run a loop. And then our S is going to equal to X times S. Alright, so we're going to go ahead and run this and then see what our values for S, U, V, and P are. So I'm going to hit run. Gives our UVP. I'm going to wait to get our R and then S values. Okay. So I'm just going to scroll up. Actually, just bring this down. Give it a lot more. Cover a lot more. When you scroll up, you see our U is 1.0428. Our V value 0.9590, and our P of 0.5355. Then what you see for our R is that since we run this for 3 years, we have the first S value of 104.2764, second one of 108.7356, and then the third one at 113.3855. Okay, and then for part B, basically have a similar code. Our U, V, and P still have the same formulas. Our N this time is going to be 200. Our S is still 100, and then we have our S max equal to S. Our H is also 1 over 252, which is different from A, which was 1 over 52. And we run the same loop, but this time our X is a binary of 1P. And then we want to find the loss and then the loss is equal to x max minus s at 756. We'll go ahead and run this and then see our values, and then also see if we can get the histogram to show. Yes, so we will get the histogram showing this. So there, see our U, VP. U is 1.0191, V is 0.9813, and our P is 0.5162, and this is our histogram showing the loss.